Okay, we're back here for part 2. We're going to do problem number 4. Let's draw the net for it. So the base is a square this time. Remember last time it was rectangular. All right, so we're going to draw it. It's 4 feet on each side. And then from each side we've got a triangle coming out. Sorry, I'm so bad at drawing these. This one's not even going to make it to the edge, so we'll just draw it like that. And then the bottom one's going to look like this. Okay. Now, because the base is a square, right, all of these triangles that come out of it are identical. So like in the last one, we had to find the area of these two and then the area of these two because they were different, but now all 4 are the same. So we're just going to find the area of the square base and then the area of one of these triangles and multiply it by 4. All right, so let's write that down. Surface area is going to be the area of the one square base plus the 4 triangles. All right, and the other nice thing about this problem that we did not have in the last one is that they tell us what the height of this triangle is when we flatten it out. So here the base is 4, and then they tell us that the height is 12. All right, so if you remember last time, they had this line drawn in that where we dropped a perp from that point to that plane, and they gave us that height, but not that slant height. All right, so we had to do Pythagorean theorem to find the slant height. They were much kinder to us this time. They gave us the slant height and not that the height of the pyramid. It doesn't actually matter what the height of the pyramid is when we have the slant height. Okay, so this one should be easy. The area of this square is just, again, we could do length times length or side times side. I'll do length times width or side times side. The length and the width are the same. They're both 4. All right, so the area of that square base is 16. And then the area of the triangle, sorry, I'm jumping ahead here. We have 4 of them. And each of them have a formula of 1/2 base times height. All right, the 4 and the 1/2 right away are going to cancel out and make this a 2. And then we're just going to have to do base times height. All right, so the base of one of these triangles is 4. And the height of one of them is 12. Now, I went to different triangles. It doesn't make a difference. I could say the base is 4 and the height is 12. Here the base is 4 and the height is 12. I just didn't have the height drawn in that one. So it's the same in each of them. Base 4 and height of 12. Same thing here. Base is 4, height is 12. Okay, so then we've got 16 for the area of the square base plus 2 times 4 times 12. 2 times 4 is 8 and times 12 is 96. So we've got 16 plus 96 is 112. 6 and 6 is 12. Put down the 2, carry the 1. Yeah. All right, so it is 112, and then the units were feet, so this is feet squared. That one was a piece of cake compared to the last one. All right, you're going to do the one that's just like this, which is problem number 5. So if you go to do problem number 5 and you can't remember, come back and watch the video for number 4. Okay, I think we actually have enough time to do then problem number 8. Nope, sorry, 7. All right, number 7 is also easy compared to problem number 3 that we did. Okay, so we have another pyramid here. The difference is it's not a rectangular base and it's not a square base. This is actually a triangular base. So, and we notice based on the markings here that it's actually an equilateral triangle. They tell us that all 3 sides of this are 10 inches. All right, so when we go to draw the net, we're going to draw an equilateral triangle. I'm going to do my best to draw an equilateral. So let's go with something like that. Okay. And then we're going to draw a triangle that comes off of each of them. Now think about this. Each triangle, since it has the same base, the same measurement here, and it's meeting at the same point up top, each of those 3 triangles that we're going to draw should also be congruent, right? Just like the 3 sides of this triangle were congruent. The 3 triangles that come off of the triangular base here should also be congruent. Sorry, I'm trying to draw around a tripod leg, so it's a little bit tough there to get it right. Okay, so pretend that they're congruent. Let's maybe come out here. Okay, so then let's put in the measurements. We know that each of these sides is 10, 10, and 10. They give us a lot of extra pieces of information. They tell us that the distance from here, to the foot of the perpendicular, is 8.66 inches. All right. So if we were to draw like from here to about here, that's 8.66 inches. We don't really need to know that for our for this triangle right here. And we can actually figure this out on our own right here. Because we know that's an equilateral triangle. We'll talk about that in just a second. What we really need is to find this measurement right here, because this is the height of all three of our congruent triangles right there. And fortunately, they give us that piece of information on this triangle right here. They tell us that the height of that triangle is 13. So it's going to be 13 and 13 and 13. There's another piece of information they give us here, and that is that the height of the pyramid is 12. Again, not necessary. We have this information here about these three triangles, and we can figure this one out. We've done a couple equilateral triangles before. So let's then write our formula down here. So the surface area is going to be the one equilateral base. Pretend that looks like an equilateral. And three of these. All right, so the one equilateral base and the three other non-equilateral triangles. Let's tackle these first because these are easier. All right, so surface area is going to be, we'll leave room for this, plus we have three of this. So how do we find the area of that? It's 1/2 base times height. We have three of them times 1/2. The base of each of these triangles is 10, and the height of each of these is 13. All right, I'm going to go with 1/2 of 10 is 5, so we've got 3 times 5 times 13, and then 3 times 5 times 13 is 195. Right, so the area of these three triangles right here gives us the 195. All right, now let's go back and focus our attention on the equilateral triangle. That's going to be the harder part of this because they didn't give us the height of that. So let's come off to the side here and think about that. We actually did this last week when we were talking about the hexagon, how it was broken up into 6 equilateral triangles. So we're going to do the same thing again here. So we know that this is 10, this is 10, and this right here splits this up into 5 and 5. We also know in an equilateral triangle, this is 60, this is 60, and when we split this down the center, this becomes a 30 and a 30. Right, so we have two 30, 60, 90 triangles, one to the left of that vertical line here and one to the right of it. And we know that this is 5, that's our x side. This is our hypotenuse, that's our 2x side, which matches with what we would expect, because if this is 5, 2 times 5 is 10. So really all we need to do is find this side right here. And if you remember, this side in the center right there, the height is the x root 3 side. And so it is 5 root 3. All right, so if we go to find the area of this triangle, let's go back over here. It's 1 times 1/2 times base times height. All right, the base of this triangle right here is 10. And the height we just found is 5 root 3 right here. All right, 1/2 of 10 is 5 times 5 root 3. This is 25 root 3. All right, so I'm going to add 195 and 25 root 3. And I get 238.30. And this is in inches, so it's inches squared. And that's our surface area. Okay. This one matches up with problem 8. So when you go to find problem 8, it would be just like this one. All right, thanks.